Hello, my name is Mark Patterson and I'm with Go Measure 3D, and today we're going to be doing a simple scan using the R3x, and we're going to be scanning a Nike shoe. So let's get started. I've already calibrated everything, so everything's set up. So I'm just going to come over here and hit scan, and I'm going to let the rotary table do the work for me. So what the rotary table is going to do is it's going to automatically rotate our part and scan it, and then continue that process until it's done. Now, if you look closely, you can see a pattern being projected onto this part. And it's a bunch of vertical lines, and what we call that is the fringe pattern. And the fringe pattern allows our two cameras on the side of the projector to take pictures and capture data points based upon these lines. So each scan is roughly 2.2 million data points. So we're just going to let this finish up, and once it's done, the rotary table will actually automatically align and automatically combine all of our scans into one scan with the proper orientation. So let's just wait for that to finish up, and once it does, we'll take a look at it. So now it's done, let's take a look at the data. It looks pretty good. Looks like it caught some of our table and a little bit of the sheet. So let's take a look at it. Really crisp, really clean data. You can see the stitching on the Nike symbol and the stitching in the other places on the shoe. We come up here, we can see it got the perforated holes on the shoe on the tip of the foot. But we're still missing the bottom profile, and that's pretty easy to get. All we really have to do is flip our part on its side on the rotary stage and take another set of scans. So let's go ahead and do that and press scan, and it'll run through the exact same process that I described earlier. And once it does, we'll go ahead and we'll begin aligning. Alright, so it's going to combine our scans, and once it does that, we can begin the manual align process. Alright, so let's delete the data caught from the table, and let's do this. So to manually align two scans together in FlexScan, all you have to do is get it in the same orientation as the other scan. The way the manual align process works is by a process of picking similar and overlapping scan data and kind of meshing it together. So I've just aligned the two, and that's pretty close. So I'm going to go ahead and I'm going to combine the two scans together, and once they're combined, we can run through the finalization process. Alright, so last thing you would do is press finalize, and we have two options, a precise merge and a smooth merge. Precise takes all data as is and does not alter it, while smooth merge smooths out some of the rougher states in it. I'm going to use a smooth merge for this object, and I'm going to use the hole filling option. And I'm going to go ahead and I'm going to click OK. Alright, so now that that's done, it's pretty much ready to be exported out as an STL. One thing to note though, sometimes you will have holes still left in your mesh after you finalize. FlexScan offers a very useful feature called hole filling, where all you have to do is just load it in and select your holes, and it'll go ahead and it'll fill all of the simplest holes, and then the more complex holes like that you would have to fill in yourself using a bridge method where you just click and drag between the two and then fill it in. So that's all I'm going to show you, apart from the last thing, which would be exporting it out, which really is just a click of a button. So you have your scan loaded, and all you do is click export and choose a file location and press OK. And that takes a couple of seconds to export out. So thank you for watching, and that's it.